Okay, so this tutorial I'm going to look at covalent bonding. So guys, up until now we've basically only looked at ionic bonding. Ionic bonding we said was like a marriage, where the metal is the guys, the non-metal is the girls. So a metal basically marries or combines with a non-metal. It's always the guys who are the losers. They have to give the girl the ring. The metal's name traditionally goes first, and it's the non-metal, the girl, who the ending of her name changes. Now here we're going to look at covalent bonding. It's a little bit different. Covalent bonding is actually between nonmetals. So it's when two or more nonmetals bond together. So we're looking at a bit of a girl-on-girl action here. Now covalent bonding, nonmetals don't have enough electrons to just be giving them away. All right. Remember, most nonmetals are just trying to gain one or two, maybe 3 electrons to fill that outer shell. So essentially, guys, for covalent bonding, when two nonmetals bind, what they do to overcome that is they share electrons. So rather than gaining or losing, they simply share electrons with each other till they both have a full outer shell. So let's have a look at how that can actually work. All right, before we do that, we'll just put a note there. So covalent bonding is, guys, when nonmetals share electrons. Okay, and it's not a complete definition. I suppose we should put it's when nonmetals share electrons in order to gain a full valence shell. Okay, because again, when they gain a full valence shell, that's going to make them a whole lot more stable. Okay, so let's clear that and look at a couple of examples. Alright, so the first example we want to have a look at is H2O, so good old water. Water is actually an example of a covalently bonded molecule. Okay, so we've got the oxygen and hydrogen are actually sharing electrons. And that makes sense. You should be able to tell straight away. Hydrogen, even though it's on the metal side, remember that's the exception. Hydrogen's a non-metal, oxygen's a non-metal, so two non-metals, it's probably covalent bonding. So if we draw oxygen, make it a little ox, okay, otherwise it just often looks like a circle. So oxygen is number 8 on the periodic table, so it's got 8 electrons. That means it'll have 2 in the first shell and 6 in its second shell, or energy level. So 6, we draw them singles first, 1, 2, 3, 4. We got 4, and we'll make it 6, we'll put another one at the top, and we'll put another one at the bottom. So oxygen's got 6. Now hydrogen is number 1 on the periodic table. So if we draw hydrogen, it's got 1 electron. Now it's not going to want to just give that away. Hydrogen's already only got 1, and if it gave it away, basically hydrogen would just be a proton. So it's going to hold on to that electron quite tightly. But again, it would like to get a full outer shell, and oxygen here would also like a full outer shell, but neither is willing to kind of just give away an electron. So what we can do is actually this. We know we've got 2 hydrogens in there in the formula, H2O, but what we can do is a hydrogen can come along and put its electron right here. So now hydrogen is actually sharing its electron with oxygen, but also oxygen is sharing its one with hydrogen. We've got 2 here, so hydrogen now has 2 electrons in its shell. Alright, so that's what's going to make it stable. On the other side, we can get another hydrogen doing the same thing. So another hydrogen sharing its electron with oxygen. And if you look now, the hydrogens both have 2 electrons, which because it's that first shell, that counts as a full shell. And oxygen now has 2, and it now has 8 valence electrons, so it too has a full shell. So by sharing them, by overlapping those rings, we can essentially get full outer shells. The whole thing's a whole lot more stable, and that's an example of a covalent bond. So guys, there are several ways you can actually draw this. So I'll show you one of the other ways that you can draw this, and that's basically just using, so that was a Bohr diagram. You can do it with Lewis diagrams too, and in fact I often much prefer the Lewis diagrams because to me they look a little bit cleaner. So again, if we start with, I'll do it in red this time, oxygen. Oxygen has 6 valence electrons. 1, 2, 3, 4. Let's make it 5. Let's put the other one on that side too. So 6. Okay, so remember a Lewis diagram, it doesn't have rings, and it just shows the valence electrons in the 4 positions, left and right, up and down. Now if you'd put the doubles up and down and the singles left and right, that's fine. It's all just about the number of dots, the number of electrons we're showing that it has in its valence shell. So oxygen was number 8 on the periodic table. It's got 2 in the first shell. In this case we don't show those. In a Lewis structure we just show the 6 in the outermost shell. So now the hydrogens can come along, and you can see based on how I've drawn it this time, we'll have to go up and down, but a hydrogen can come along from one side and share its electron, and a hydrogen can come along from the other side and share its electron. And now they all have a full outer shell. Hydrogen's got 2, oxygen's got 8. They're all happy, and that's going to be a whole lot more stable. So again, if you draw it this way, or if you put the hydrogens left and right, we're not really too fussed. Generally, I guess people would put them left and right because they just fit better on a page, but it's not really the important thing. The important thing is the number of electrons, and just showing how they're being shared. You notice for the hydrogen here, I used crosses instead of circles. I like to do that just to show, you can see this electron came from the hydrogen, whereas the other one came from the oxygen. So you can just see how it kind of pieces together, but you can just do them all as dots, that's fine too. Okay, let's do one more example. So that was H2O. Let's do CH4. So this is methane gas, CH4. So we're going to draw carbon. Carbon is number 6 on the periodic table. So that means that it has 6 electrons, which are arranged 2 and then 4. So 4 valence electrons. So carbon has 4 valence electrons. So doing a Lewis diagram, just the 4 valence electrons. And hydrogen has 1 valence electron. In this case we've got 4 of them. So if they each share electrons with the carbon, okay, you can see now carbon's fully surrounded. It's got 8 valence electrons now. Hydrogens each have 2, which for it, because it's the first layer, that counts as a full shell. Everybody's happy. We're kind of stable. So again, that's just the Lewis structures. I like doing those. They're a lot quicker and they're a lot tidier for me. But we'll do the Bohr diagram as well, just to make sure you can do both. So doing a Bohr diagram to show that bonding, we said that the carbon is number 6 on the periodic table. So if we do the Bohr diagram, it actually has 2 in the first shell. Carbon has 2 electrons in the first shell, and then it actually has 4 in the next shell. So we had 2 in the middle, make those a little bit bigger, and then it has 4 electrons in its outer shell, 1, 2, 3, 4. Okay, hydrogen just has the 1 electron. So if we draw that one in, the hydrogens, hydrogen can share an electron over here. Oh. So hydrogen can share an electron over here. Get another hydrogen sharing an electron over here, and a hydrogen sharing an electron over here. Okay, so that's the Bohr diagram. It's basically the same, except it's got the rings, and we show the inner layers of electrons too. So methane, CH4, has 4 valence electrons, and each hydrogen shares one with it to give it a full shell. So again, the hydrogens have a full shell, those 2 electrons, the first shell only holds 2, and carbon, it's got a full shell, it's now got 8 too. So everybody's happy, a whole lot more stable, and that's basically it, guys. That's covalent bonding. So it's just a matter of pairing up those unpaired electrons so that both elements are happy that they have a full outer shell. In the next video, we'll look at a couple more slightly complicated examples. We'll look at when there's not enough electrons to go around by pairing them up like this. What do we do then? So we'll look at a few examples that get a little bit more complicated. but actually they're pretty straightforward too. They're not too bad. So guys, that's how you do diagrams showing covalent bonding. You can either do a Bohr or a Lewis structure. In a test we might specify which one you have to do. But guys, it is really just about overlapping those electrons that are shared so that each one gets a full outer shell. Cool, I hope you found that helpful.